for my learners. All right, so we're going to construct histograms and what's called frequency polygons. And this is, well, you can't even see it. Hi, there we go. These are like pretty much the directions that you're going to want to do with these. Step number 1, you need to draw and label an X and Y axis. More particularly, for those who are more familiar with quadrants, you do it in quad 1. You don't do it in quad 2. You don't do it in negatives, usually, okay? I haven't seen a histogram that goes below the x-axis, okay? Step number 2, on the x-axis, okay? I can't even spell. On the x-axis, you need to label the class boundaries that's important for a histogram. So I'm going to write for a histo. You label the class boundaries on the histogram. When we do the frequency polygon, you don't label class boundaries, you label midpoints. Label the midpoint. And I'll show you this when we do our example. And that's for the frequency polygon. Okay. So 2 different things there because we're doing two graphs today. We're going to do a histogram on one, and we're going to do a frequency polygon, and you'll see what I mean when I talk about labeling your x-axis. And then last but not least, we're going to plot the frequencies for each class. Plot the frequencies for each class. All right. So here's what they're going to do. We're actually going to do the same one we did from our notes about the age of the Declaration of Independence signers. That was the last class, right? We did age of Declaration of Independence signers for those who watched the video or for those who actually were in my class and listened. Okay. This is what they're going to give you on homework tonight. They're going to give you, so here's our example. You can write this down or it's in your notes from the last time. They're going to give you the class limits. So they're going to give you 27 to 30. They're actually going to do this work for you. So that's good news because you're like, I'm so done with doing this work, Mrs. Setter, right, Jonathan? Like, not again. I can't count to save my life. I agree. Counting is torture. All right, so this is what we had already done. This is what they give to you. This is right here in the green is what they're giving to you. This is what you have to figure out. This is what you have to figure out. You have to figure out the class boundary. Now, we did class boundaries, or we did boundaries on our last test. That was the only mathy thing we did, right? Do you remember the rules for boundaries? What do we have to do for boundaries? It always ends in a 5, and then you have to go one more decimal place over from what it is. So 27, the boundary for 27, you would actually round it down to 26.5. And the boundary for 33, you would round that up to 33.5. So then what would be this boundary? What would you say would be this one right here? 34 would become what?
33.
33.5. 40 would become 40.5. And just keep going. This would become 40.5. Notice how whatever it ends here, it's ending here. Okay? For the boundaries, they're allowed to repeat. For the boundaries, they can repeat. 40.5 to 47.5. 47.5 to 54.5. So this part you have to do. Just know to round down, round up, round down, and round up, okay? Then you're going to get your frequencies. You don't have to tally it, but you can get your frequency. Count up how many there are in that class boundary. And what we had already done that really. So we're just going to write down copy the numbers. 7, 14, 15. There was 11 in here. 3. I'm sorry, this is kind of curvy. And then 2. Okay. So here's this part right here, you'll have to do, this part you'll have to do. You can just do the frequency according to the class limits, but they would also fall within that boundary. Okay. Then here's how you construct a histogram. A histogram is essentially a bar graph. It's just squeezed together. Okay. We need in a histogram to plot what's called the boundaries. We don't plot the limit, even though this book will change it on us and they'll start graphing limits. But that's not what you want to do. You want to plot the boundary. So we're going to title it, because you always should title your graph so we know what we're talking about. This is the age of the Declaration of Independence signers. You always want to give it a title. Title, what does this mean? What is this talking about? Then you're going to draw your X and Y axis and you're going to label them. That was the first step I said. So here's your X axis. Notice you're in quadrant 1. Here's your Y axis. Your Y axis is always the frequency. Okay. Your X axis is your boundaries for their ages. So you can write ages, but we're going to plot the boundaries. Okay. So my lowest boundary is 26.5. So you could write that all the way up to the edge here. I've seen books where they go like that. I've seen books where they put it right there at 0, 0. It doesn't matter. And then you go up to 33.5. And then you go up to 40.5. And then you go up to 47.5. You see where I'm getting those from? Those boundaries right here. 47.5 to 54.5. That's why we wanted to make sure these two numbers end the same. 54.5 to 61.5. Am I going to make it? 68.5. I'm not. Oh, I am. Yeah. 75.5. Okay. And then you draw boxes. I know this is exciting stuff. What do you mean I draw boxes? Actually, let me label this too. I should label, what's my highest frequency? 15? So, you can go up by 2s. I'm going to go by 2s. 2, 4, 6, 8, 10, 12, 14, 16. There we go. All right, so now let's draw. The 26 to 33.5 has a frequency of 10. So you are going to go like this. And you can go all crazy and decorate it if you want to. Okay. And then this one is 14. Pretty. And then 15. And then 11. I mean, aren't you feeling like you're back in the 7th grade? You are, for a little bit here. What is this, 11 again? No, did I do 11? I've lost my train of thought. 15, 11, there we go. 3 comes next. 3, and then 2. Look at that. And that's called a histogram. Righty. Now, frequency polygon is just one more little bit of work, but actually I'm going to show you a trick, and you're going to be thankful that I showed you this trick, because I'm going to let you do it on homework tonight. But you have to make sure you know what you're talking about if you do the trick. If you don't do the trick, I'm going to get mad at you. Okay? Y'all got this down? Easy breezy. Okay, take this same information. They'll give you, again, they're going to give you these class limits. You have already found the boundaries. And we're going to do now a frequency polygon. So we have our class boundaries. We're going to do it for the same thing. And let me just copy these again because it bothers me if I don't have it right. 33.5 to 40.5. 40.5 to 47. You don't have to copy this if you don't want to. If you want to just kind of squeeze it in somewhere, I'll show you in a minute where you could squeeze it in. $61.5 to $68.5, and then $68.5 to $75.5. Okay, so now here's the other work that you have to do, okay? Because we're doing now a frequency polygon, frequency poly. You have to find what's called the midpoints, okay? On a histogram, you find these, the class boundaries. On a frequency polygon, you find the midpoints. Midpoints, do you remember how, and maybe you, in pre-calc, maybe in AFAM, you should have learned this. Do you know how to find the midpoint of a number, like two numbers on a number line? What do you do with them? Like, what's the middle of 10 and 15? What would you do? You remember what to do there? Anybody? Really? You're brilliant. You add them together and divide 2. That's the middle. That would take an average, add them together, divide by 2. Okay? So you need to find the middle. You would take your upper boundary plus your lower boundary point and divide it by 2. So if you take these two numbers in your boundary, your upper boundary, add it to your lower boundary, divide it by 2, you're going to get a midpoint of 30. Here, add it upper, lower, divide by 2, you're going to get 37. Take a guess what number comes next. 44. Take a guess what comes after that one. 51. What are you doing?
Adding 7.
Adding 7. Where did that 7 come into play?
With
Class width. That also works out here in the midpoints. So take those midpoints, and then again, your frequency, we already established those frequency. It would be the same frequency, 7, 14, 15, 11, 3, 3, 2. Okay? Now, so you could have made like an extra column over here of midpoints. That's totally fine with me. You could have just done that and then like put this all into one picture. I'm just showing you into 2 separate pictures. Now, how do I actually draw the frequency? So it really looks the same again, okay? Except instead of labeling the boundaries on the bottom, you're going to label the midpoints. So you're going to put 30, 37, 44, 51, 58, 65, 72. You're still going to have the same y-axis up here. 2, 4, 6, 8, 10, 12, 14, 16. And then you're still going to plot the frequency, but you're not going to make a box. You're going to make a dot. You're going to go like this, all the way up to 7, dot. 37 goes to 14, dot. 44 goes to 15, dot. 51 goes to 11. 58 to 3, to 3 to 2. And guess what you do with that? You connect the dots. And that's called a frequency polygon. You may be like, well, that looks like a line graph to me. It's the same thing. Except remember, these are the midpoints. These are the frequencies. You always want to label. Now, how could I have done this easier? Mrs. Seta, how could I have done this easier? And I'll let you do this if you can remember it, okay? Because on the test, they're going to give you this. But on your homework tonight, on the 4 questions I ask you to do, I just want you to watch this. Let me actually darken it. Maybe you can. Can you see it through? No? Bummer. What if I did this? Guess what's in the middle of 26 and 33.5? I think we just established it. What was it? 30. What's in the middle here? And look where that lands at, 7. What's in the middle here? What's in the middle here? 30, 37, 44, 51, 58, 65, 72. Connect, connect, connect,
Crazy.
connect, connect, connect. Just lay one on top of the other. Just know, though, that you need to have a 30 right here, okay? Does that make sense? So the brown graph that I'm drawing is the frequency, yes. The blue graph was the histogram. So you can combine 2 and 1. I'm totally okay with that. But do you understand that the histogram actually looks like this and the frequency actually looks like this if you were to see it on an actual worksheet? But you can just combine them. Because why are we having to maybe make 2 graphs, Mrs. Said? Exactly. Let's just make one. Let's just connect the dots, connect the tops of the bars. That's it. All right. Now, with that being said, wait. One more last thing. And this isn't hard. This is easy stuff. This is very important stuff, though, what we're about to write, okay? This is called distribution shapes, and we're done. Very important in math, okay? In mathematics, your bar graphs, these histograms, okay, come into shapes. And the most well-known shape that you want on any of your data is what you see right here. This is called a bell-shaped curve. You need to know these. They're going to ask you what's the shape of your histogram today. If your graph looks like this, where they're all kind of looking like they're leveling off, that's called a uniform shaped. Okay? These two are important. If you have a bunch of bars that are stacked here and then they kind of drop like that, okay? So what I tell my students is go to the highest bar you see, go to the top, and then would it take you longer to go down to the right or would it take you longer to go to the left? Take you longer to go to the right, right? This is called right skewed. Some books say positive skewed. Guess what a left skewed would look like?
The other way.
It would go the other way. Exactly. You'd have a little boxes and then all of a sudden you'd be stacked up here. So if I went to the highest bar and I went down for, right on the slopes, I'd go left. This is left skewed. These are very important. I know it seems weird, like, yeah, duh, okay. When we start doing our actual data and our analysis, we want things in a bell-shaped curve. If we have left skewed and right skewed, that means we probably have data that we don't want to look at. So for example, the grades in my pre-calc and calc class are usually skewed data. It should be skewed data because they're higher, they should be getting A's on everything. Whereas if I took a normal regular math class, I probably would have more of a bell-shaped curve. So we need to know this information. Positive or negative skewed, they'll say. And then 2 more looking things. You could have what's called, make sure I'm drawing this right. Ooh, there we go. I'm sorry about my bar graphs. But you have what's called bimodal. You have 2 tops, 2 peaks. Okay? This is a bimodal. When you have 2 high points, okay? Even if this was slightly higher, it would still be probably bimodal. You would just assume it to be bimodal, okay? If you have 2 high points, 2 peaks, bimodal. And then the last one is like this. Your graph goes like this. And you don't want to say it's bimodal. You actually want to say, because you're ending up high and then you're starting high and ending up high, you actually have what's called a U-shaped. I've rarely seen U-shaped graphs. I've seen bimodal, I've seen bell, I've seen right and left skewed, okay? Uniform shapes don't really come into play into data that we're looking at, but so they will ask you on tonight homework, after you draw your histogram, they'll ask you, well, what was the shape of it? So if we just go back with me real quick, what would you say the shape of that one is? Is it bell?
Right skewed.
It is right skewed. If you go to the top and go down to the bottom, it takes longer. Good job, y'all. That's it. right, so your homework, 4 whopping problems. I only want you to do histogram and frequency. If it asks you to do any other kind of graph, you say, no book, no. Okay, and you may lay one of the frequency on top of the histogram. I'm totally okay with that, because why should we make 2 graphs when they're kind of the same? Okay, and then obviously it will ask you to tell me what the distribution is. Y'all got the rest of this time. You need to finish that homework or you're gonna get a 0, and that's not gonna be good. Okay, I've given you enough time now. Finish it fast. Fast but accurate. Fast but accurate. "20 minutes. You should be able to get your one problem done."
It's the same as those.
20. Do it, Sean.
How'd you get these class boundaries?